All right, in this video, we're going to take a look at the process of solvation and the word solubility. So the word solubility is talking about the process by which a solid, and not necessarily a solid, but where a substance dissolves into another. And we often in chemistry look at a solid dissolving into a liquid, but there are a solution can be made of any state of matter. So gas could dissolve in a gas, a liquid into a gas into a liquid, any variation of that. But we'll just here look at the type that we most commonly deal with in chemistry, and that is a solid into a liquid. So here we have the common solid NaCl. It's been assaulting people for years, and we're going to take this salt NaCl and we're going to add it to the water. So a couple terms here for you to know. First of all, the solid substance, when we're talking about solubility, is known as the solute. The liquid, which in this case is water, is known as the solvent. A good rule of thumb for a solution, that was really messy. A good rule of thumb for any solution is that the solvent is the thing that's in greater concentration. And water is known as the universal solvent. So this will dissolve most of our solutions that we make in chemistry. If you imbibe in an alcoholic drink, that is alcohol dissolved in water, and that is also a solution, as an example. And so what we see when we put the NaCl in the water, we see the NaCl, which here is a solid crystal structure. So we zoom in on the picture down here, we can see that we've got our chloride ions and the sodium ions, and they make up this crystal lattice. Once placed in the water, the crystal lattice breaks up, and you are left with separate ions. So the chloride ions and the sodium ions become separate, and this process is known as dissociation. So the sodium and the chlorine are all like, I don't want to be near you, and so they split up, and they become dissolved in water. And you can see here the process. The water molecules with their polar ends attract the ions and are able to solvate the ions. You're learning all kinds of new vocabulary in this video. But they solvate the ions by pulling them away from the crystal lattice. And in that way, they slowly break down the solid until it's no longer visible. Mentioned earlier, a solution does not have to be a solid dissolved in water. We have many different examples here. So air, natural gas, it's a gas solution with a gas dissolved in a gas. We can have a liquid dissolved in a liquid, as I said, vodka and water. We can have a metal, brass, so two solids dissolved in each other. And we did that one earlier in the year. That's where we took the penny and we dissolved it. We took the zinc and we dissolved it into the copper on the penny. You can have gas dissolved in a liquid. You can have solid dissolved in a liquid. So these are all possible types of solutions. But most commonly, we work with this one, with a solid in a liquid in chemistry. So this is the one that we'll be doing most of the time. The last thing about the process of dissolving substances, there's a saying in chemistry that like dissolves like. And what that means is that substances that are polar will dissolve substances that are polar, and substances that are nonpolar will dissolve substances that are nonpolar. But polar and nonpolar substances will not dissolve. So oil and water, oil is nonpolar, water is polar. They will not mix. And the reason that this happens is we can see here, it's because, say, something like alcohol, which is polar, has an OH bond on it. And so we can see here with the OH bond, we get the negative oxygen and the positive hydrogen. When a water molecule comes close to that, the negative end of the water molecule will be attracted to the positive hydrogen, and in that way they'll attract each other, and that solvation process can occur where water molecules can surround this alcohol and dissolve it. And so that's why polar molecules dissolve other polar molecules, and it leads to a great joke to end the video, and here it is. Hope you enjoyed the video. If you have any questions, as always, email me, and copper tomorrow.